Hey, we made it just in the nick of time. Hey, everybody. But again, it is 2 hours UTC. This is Astronomy Daily Live, coming at you every single day, right here, right now. So hope everybody's doing okay. I'm going to go through sort of my regular couple of minute startup here. You know, once the live stream goes, I've got this live camera machine here, and I've got this Linux machine over here that runs my chat, which the chat is about to pop up. OMC XXX in the house. Thank you, sir. Thank you for coming in. Glad to see you again. Looks like the bright lighting continues, and it looks pretty good. I'm going to unlive this one. And I meant to pop the chat out, and instead I looked at the list of participants. So just gathering in the circle here, circle of friends. All right, so there I've got my live chat. So now I'm going to go over to my smartphone, and I just run that live in the background so I can sort of look over once in a while and make sure that the live stream is still going. A lot of other podcasts seem to have a lot of technical problems, and I'm really new at this, so I don't know yet. so far this Google Hangouts YouTube live stream thing is pretty simple. So yeah, I'm glad about that. I actually just opened this computer up like 4 minutes before I was going to start, and yeah, that's cutting a little too close. So I need to maybe set myself an alarm or something to deal with that. So yeah, hope everybody's doing good. Hope all you folks in the future who are watching this not live are doing well and having a good time out there. As I said, this is Astronomy Daily Live. This is a casual, open-minded, skeptical, educational, fun gathering of friends to talk about astronomy every single day. There is so much to talk about in astronomy that having just one daily show isn't enough. It's just not enough. So plans are, to maybe have more than one show a day, mainly to accommodate this theoretical spherical world we're on. Dennis Hands, and I'm going to give a shout out to Dennis Hands again. He's a 40-year educator, and I don't know if it's specifically astronomy or if it's just science, and part of the curriculum was astronomy, but he's got a great show on Snapchat. I believe it's every Monday and Wednesday. In my head, I'm not remembering exactly what time. But if you go on Snapchat, and I think his handle is Dennis R. Hands. He also has a Twitter account, which he posts once in a while. Get a hold of him, and he hasn't responded yet, and that's cool. hopefully he'll come on and be part of the circle here. So, hey there, Lord. Hope everything's okay with you. Good to hear. Yeah, just watch the Atlas 5 SBIRS. I think that's what it is. It's a Air Force satellite that apparently looks down at the Earth in the infrared. I guess primarily to detect missile launches. So there's a lot of things that you can do with a big telescope looking down in the infrared. So I'm sure it's just not that, but they're not going to talk about it. So, but it was a good launch. It was a 411 configuration, which always looks a little strange to have just one solid rocket on the side. It looks off balance a little bit, but it's very cool anyway. And that's one of the things that I haven't seen or experienced yet is a rocket launch. So. Yeah. So, but it was a good launch. Looks like everything went off okay. There's also a launch that's supposed to be going off sometime soon from what are those guys? You can get it here. And they're launching over in New Zealand. Let me see if I can quickly find the link for that. So far, you guys are the only two viewers and me. Rocket Lab, yeah, the Rocket Lab launch. I think is this? I don't know if this is supposed to be an orbital or if it's just up and down flight. But yeah, so that's going to be happening, I guess, later tonight if it happens at all. I think they're still up in the air in terms of that. Got the hydrogen hydroxide tonight. It's always a difficult choice whether I want to go with the dihydrogen oxide. Some people like to pronounce that dihydrogen monoxide, and either of those work. I would have to look up the chemistry rules, I guess, to to really know. But my choice tonight is hydrogen hydroxide. So yeah, cheers. I'm going to switch back to the chat here, see if you guys are doing well. Okay. So let's see. Much that can be talked about. So as I said, whether you're a newbie to astronomy or an amateur or an advanced amateur or a pro, there is a place in this circle for you. This is just a gathering of friends, right? A daily gathering of friends just to, catch up with one another and catch up on all things astronomy. And at least for the time being, I'm going to be doing it at 2 hours UTC every single day. Now I'm located in southeastern Arizona in the United States, and I'm on Mountain Standard Time. and and I'm always on Mountain Standard Time. Arizona is one of the handful of states or localities that does not observe daylight savings time. So I am always 7 hours behind UTC. So my local time right now is 7:10 p.m. So depending on where you are in the world, you're going to have to take 2 hours UTC, and you are in relation to that. So that means it's 2 o'clock in the morning in England. So, probably not going to get a lot of European viewers, maybe get some Asian viewers, hoping to hook up with some Australians, because this is a good, it's a little early. No, it's going to be around noon in Australia right now. Yeah, something like that. Something like that. Maybe early afternoon. Yeah, so really this particular time, the only thing that it really misses is Africa and Europe. So and that's a pretty big chunk. So that's why I'm trying to think about maybe doing a second show, maybe 2 shows that are 12 hours apart, something like that. I don't know. Have to think about that a little bit, but for sure, every single day, unless something comes up, and I'll try to at least post something about that if I'm not able to make it one particular time. I will try to let you know, but I purposely lead a pretty simple life, so I'm not busy in a sense that I'm having to run around and uh, go places and be here and be there and run around and all that kind of stuff. I'm very busy at home here, working on my stuff and just doing home things. Um, so yeah, so here it's yeah, just a little bit after 7 p.m. So uh, most conversations I would really like to have you directed by you folks out there, and not necessarily just a Q&A type of thing, but a real discussion as if we were sitting in a circle and chewing the fat about astronomy, right? But we can do Q&A. I reserve the right, to ask questions as well. I am just the host. I am definitely not the answer man by any means at all. So yeah. Uh, Q&A is good. We can talk about observing. We can talk about gear, telescopes of any size. Talk about cameras and other kinds of instrumentation, photometers and spectrometers, polarimeters. There's a great and very, very active Facebook group called Smartphone Astronomy. Shout out to them. It's a very, very active group. And yeah, people take their smartphones, right? Stick them onto the telescope and take pictures, and either through the telescope itself, or they also take wide field shots, star trails and photographs of the constellations and that kind of stuff. So very, very cool. We can talk about data analysis and what astronomers do. Being an astronomer, I can at least tell you my experiences and my observations of other astronomers. We can talk about various aspects of research, what what it is, to research and study astronomical topics. Um, uh, Definitely, would at some point, like to pick out some journal articles to, review and show off, and would like to pull in, the authors to this circle as well, so we can hear stuff from the horse's mouth. That's the best way, and just let them talk. Not necessarily an interview, but just bring them into the circle and have a chat. Definitely want to talk about and show off astro art of all sorts, not only the visual arts but the audio arts. I'm involved in both of those things. I make visual art from astronomical data, and I also make music from astronomical data as well. And I actually think that the analysis of data using sound instead of looking at like a graph or a picture could be a really useful and valuable means of doing actual research, data analysis. Let's talk about the various projects, astronomical projects that are going on. There are sky surveys now, new ones that are going to be coming online soon. We can talk about specific instrumentation that professionals use, adaptive optics, all those kinds of things, and pretty much anything else that you guys want to suggest. Mrs. Elite Nugs is in the house. Howdy, howdy. Glad you can come by. Really, really glad. Oh, yeah, the reason why it's Astronomy Daily Live for the 20th of January, 2018 is because this is taking place at 2 hours. It starts at 2 hours UTC on the 20th. So it just so happens, Lord, that you're behind, and so it's still the 19th, and here it is also still the evening of the 19th. But as far as universal time goes, it is tomorrow already. So yeah, I don't know. I mean, I guess I could say that I'm speaking in the present and the future at the same time, right? And I really like the idea of a daily show, because at least for me, I don't feel as sort of pressured, that I'm going to miss a show, right? I mean, if you miss one show or two shows or a week's worth of shows, it'll be back, and exactly when, and exactly where. And so, no pressure at all, no worries at all. If you accidentally or purposely miss a show, either watch it later or forget about it and pick up on the next one. That's all. Easy. Lord, what group are you talking about? I'm not exactly sure what group you're talking about. The answer you about the date. If not, PC. Yeah. I answered that. OMC Triple X. Thanks, man. Like to know more about gravity? Yeah. Well, gravity is one at least according to the current understanding and belief, gravity is one of the four fundamental of nature. There is gravity, there's the electromagnetic force, there's the weak force, and there's the strong force. And so, being a fundamental force, that's sort of, like an axiom to a theorem, in that you sort of don't question that per se. It's just a thing that's there. That's it. That's it. So and how general relativity explains gravity, that space is actually a three-dimensional object, right? That makes sense. And matter or mass, those are actually two different things, but mass can warp space time, and that warping has the effect of what we call gravity. So it's sort of like living on the surface of like a potato chip, right? It's all bent and bumpy and lumpy, and where there are low spots, right, that's where there would be mass. High spots, there would be less mass. So it's hard to move in a straight line across that, because you're having to follow the contour of the surface of the potato chip. So if you just sort of extend that to three dimensions, that's sort of the idea. So mass, space-time, and so as objects move through space, they're going to follow the that space. That's sort of the idea. Nobody really knows, because it is a fundamental force. Nobody really knows what it is. Of this thing called the Higgs boson. It's what the high energy physicists or particle physicists over at CERN have built this huge particle accelerator. I don't know what they're smashing together, but they are looking for this Higgs boson. At least in my opinion, about is that as long as we keep looking, we're going to keep finding them. So that's sort of how it is. I don't think that we're ever going to get down to sort of the bottom of that. Yeah, it's sort of a strange thing. Supposedly, the Higgs boson is responsible for gravity. At least this is my understanding. And so, the detection of such a particle is going to help us understand what gravity is. Now, that's sort of the common belief that the high priests of science answer when asked what is gravity. Okay, but they're applying the scientific method to the question, what is gravity? You can come up with different kinds of answers that I'm interested in. that gravity is actually an emergent phenomena coming from the electromagnetic force. And in fact, there is only one force in the universe, and that is the electromagnetic force. And all the other forces are sort of emergent properties of that. Um, uh, yeah. So it's entirely possible, and there are some pretty good arguments. I'll give a shout out to these guys too. Pretty good arguments for um, the electrical nature of the universe. Um, all astronomers agree that 99 probably plus percent of the universe is made of up of a state of matter called plasma. Well, plasma is nothing more than uh, ionized matter, and ionized matter has an electrical charge. Um, so most of the stuff in the universe is plasma, and therefore has electrical properties. It is not electrically neutral. There are electrical properties associated with pretty much everything. And in fact, even in our own bodies, those ions exist. Um, Molecules are usually very bipolar, and uh, will react to electromagnetic fields and produce them themselves. So I'm just saying there's a lot that we just don't know and don't understand, and to think that we have the answer to things is bullshit. It's just absolute. That is just that's not science. Science, and I don't have my diagram here. Science is a circular thing. Okay, it's not as if you have a beginning and a middle and an end, right? It feeds back into itself. It's what's called a process fractal. Symmetrical fractal, like the Mandelbrot set. Um, well, that's a geometrical fractal. There are also process fractals. So the output of the process goes back into the input of the process, and then that is processed, and the output of that loops around, loops around, and loops around, and that's science. That's science. It's a never-ending blossoming of knowledge and understanding, and um, I personally don't want to be in a world where that ever ends, because well, then it's just going to get boring, right? And I don't know about you, but I don't want to be bored. I used up all my boredom long ago. I'm out boredom, so I'm glad that the scientific process exists. I wish that more scientists would actually apply it, instead of being so sure and think that they're right. That is historically what has happened, right? I mean, look at history, and at every epoch, we think that we know all that there is, and every single time, without mistake at all, we find out that we're either completely wrong, um, or we're not quite right. And yeah, I think it's great, and I really think it's great that there are alternatives The show is all about being skeptical, but being open-minded. If somebody, presents me with a far-out theory, I'm going to look really, really hard at that, especially if I'm interested in it. But I'm going to look really hard at that thing, right? I mean, I'm gonna rip it to shreds. I'm gonna tear it to pieces. But I'm gonna remain completely open-minded about the whole thing, because that is scientific inquiry. That's curiosity, and um, curious participant in this universe. Anyway, to give there was the Thunderbolts project. If you go to thunderbolts.info, I need to make a note, add that link to the description after I'm done. Thunderbolts. And the other thing that I can do, which it's really, really bad, I can share my screen, so I can actually go to the Thunderbolts page, and you can see Thunderbolts. So let me do that. It's taking its time. There it is. So let me share this screen. There we go. All right, so Thunderbolts project, blah 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 blah. So there it is. They have a they have an annual conference. It's past couple years. It's been up in Phoenix. So at some point, I'm probably going to want to go to. Then I'm going to feel obligated to go to the AAS meetings too. So, and in fact, the next AAS meeting is in June, and it's up in Colorado, not Denver, somewhere else. Everywhere, but these guys are definitely onto something, and they are not screwing around, and they are not kooks. Not by far. These are smart scientists, okay, who have realized that our current thinking about how the universe is operating is on the wrong track, and it started quite a while ago. It started at least 100 years ago, maybe even more, and we've been off track ever since. So yeah, this is I think it's a daily thing. Check them out for sure. Very much worth a look for sure. So I'm going to stop sharing, and I'm going to go. All right, what else is going on? So, yeah, consider this just a daily gathering of friends in a circle to talk about astronomy. Get away from the TV for a while. Get away from the news. Talk about, some things that we want to talk about and give us a little bit of joy. And yeah, this gives me absolutely great joy. I'm really, really pleased to see that the lighting is a little better, definitely a lot brighter. That's nice. This is an ongoing thing, and completely patient. extremely supportive. So yeah, and yeah, I'm freezing up a little bit too. That's kind of neat. I wonder if this is. Well, it's not getting warm or anything like that. Yeah, I was just complaining about technical problems on other. Uh, there it is, the first one. So I can just put up my peace sign here, though. I think it's on my end, that is happening. Well, I am still here, and I will be here for at least the next 25 minutes. So, well, even if this stupid thing wants to freeze up on me and everything else, I'm just gonna plow through it. No problem. No problem at all. Looks like I still got a couple of viewers, although I haven't seen the chat moving, so don't really know what's going on there. It looks like for the most part, the YouTube channel is back. Yeah, I'm gonna try to type something in chat. This is me. Yeah, that seemed to work on my end. Cool. I'm just gonna keep going here. So big shout out to thunderbolts.info. Also wanted to give a shout out to the weekly space hangout. That happens every week. Trying to think of the other ones that I've been looking at. Yeah, Lord. I guess I had some kind of technical weirdies. So what can I say? It's ain't technology great? But I'm glad you hung in there. I'm gonna get these notes out. Weekly Space Hangout for sure, and obviously that's a weekly show. Really awesome, informative, smart people, right? I already mentioned Dennis Hands, and I like Dennis a lot. Thanks. I'm glad everybody's back. It looked like it looks like I dropped out there for a little bit, but there is Warnock 69XXX. Hey man, I finally subscribed to your channel. This matter inside of this head is like nuclear neutron star matter, right? It's like incredibly dense. So some things just take me a while to figure out, and it's like, he subscribed to my channel, but I didn't subscribe to his. Okay, well, I figured that out, and so yeah, I finally subscribed. Watched a couple of your shows, so cool. So anyway, I've already mentioned Dennis Hands, and I like Dennis just from his show. He really knows his shit, of course. He's a teacher. He's a very experienced one. Been teaching for like 40 plus years. And but his show is sort of like a teaching show, which is that is definitely a necessary part of all of this. I don't necessarily consider Astronomy Daily Live a teaching show where I'm just I'm giving you facts and information about things. Dennis even has a weekly. I don't think he calls it a quiz, but no, I think he calls it a contest. But I mean, it's a quiz, right? 10 questions, and you know, you have to try to answer them. So, but really educational. Check him out. I think he does his stuff on Snapchat. So if you search for Dennis R. Hands on Snapchat, you will find him there. He does live broadcasts on Mondays and Wednesdays, and my apologies, but I don't remember exactly when. But those recordings are saved for a little while, so you can go afterwards and watch them not live. Cheers! I've got my my hydrogen hydroxide tonight. It was a choice between dihydrogen oxide or hydrogen hydroxide, and tonight's choice is hydrogen hydroxide. So yeah, cheers. Nothing like some good chemicals to stir you up a little bit, eh? Another shout out to Deep Astronomy. Tony, hey, I would definitely like to get him on this show as well. Turns out that I was in error in saying that there aren't any astronomy related shows with a host that is a scientist. Tony is at least a physicist. That's as much as I've been able to get from the shows that I've been watching of his. He does, you know, the Deep Astronomy podcast, and I believe that's every week as well. Those are mainly like an interview type of a thing, or a panel with a couple of guests. And so definitely check those three things out: the Weekly Space Hangout, Dennis Hands, and Deep Astronomy. Yeah, very cool. So, hey, let me, since it doesn't look like, yeah, this is kind of interesting. I'm not quite, you know, I'm still on a learning curve in terms of this live YouTube chat. Now, according to my information on the screen, I have one viewer, not including me. But I see how many participants in the chat do I have? Well, I've got 2 in the chat. So I guess that means that one of you isn't watching, just chatting. I don't know. I'm still trying to figure a lot of this out. But glad you're here. And as I said, you know, folks in the future are going to be watching this. So what I'm going to pull up here is, and one of the things that anybody can do, as long as you have a relatively decently sized telescope, is you can observe and record and report on asteroid occultations. This is when an asteroid passes in front of a bright star and blocks the light out from that star, usually lasting a few seconds. You know, asteroids, you know, the relative motion between us on the Earth here and the asteroid, you know, the Earth is moving and the asteroid is moving, and so the relative motion there is usually pretty fast. You know, orders of like tens of kilometers per second. Right, so moving really, really fast. But on many, many occasions, there will be an asteroid that will pass in front of a star from where you're looking, and you can observe this, as I said. You can observe this and record it and report it. And that reporting is helpful in working out the size of the asteroid and the orbit, improving the orbital parameters of the asteroid, and as I said, getting a size and a shape, how fast it moves, all that kind of cool stuff. And there are websites, and I'm going to share this screen like that. Share, and we'll do the infinity drop. Oh, there it is. So this is a site called asteroidoccultation.com, and these are the predicted asteroidal occultations that are going to be taking place over the next few weeks. And this is updated all the time, right? So as you can see at the top there, the first one is from the 18th of January. And now this isn't going to necessarily tell you that you at your location is going to have an occultation. In this particular case, what you sort of have to do here is look at this column labeled visibility, and you can sort of be like, okay, here's a Western United States one. Okay, it's happening on the 21st of January at 2:27 Universal Time. So that's during this show. Okay, during this show. And if you go over here to this link over here and click on that, it'll give you additional information as to exactly where the visibility of this occultation is going to be. Now, it's all that an occultation is. It's the shadow of the asteroid being cast onto the surface of the Earth from the starlight. So you've got a star in the background, way, way, way out there. And then between us and the star is the asteroid. And so as the asteroid passes in front of the star, it's effectively the shadow that is passing along the surface of the Earth. And that's what this path is right here. It's the path of that shadow. I can zoom in here a little bit. Okay, this is the path of the shadow. And this particular asteroid is named that, and I'm not even going to try to pronounce that, okay? But this asteroid, number 388, is going to occult this star. And, star names are a little weird. They're mainly based on, some kind of a catalog, right? So this asteroid is going to occult this star on this date at this time. And then it gives additional information about the brightness of the star. See, now this star is 13th magnitude. Okay, in order to see a 13th magnitude star, you're going to need at least a 12-inch telescope. You're not going to be able to see it in binoculars. You're not going to be able to see it with really anything smaller than 12. Maybe 10 if you're in a really, really, really dark site. But I've got a 10-inch, and I can tell you that seeing a 13th magnitude star, that's pretty tough. That's pretty tough. So you're going to need, like a 12-inch or larger aperture to see this. Up here, hopefully you can see this. This is the duration, the maximum duration of the occultation. In this case, it's a long one. It's 24.8 seconds. Um, magnitude of the asteroid actually isn't much much fainter than the star, so the magnitude drop isn't a lot. But if you're able to see the star and observe this occultation, you will definitely see it dimming. And so here is just the path of the asteroid along the surface of the Earth. So if you're in this path, anywhere in this path, and of course, this is North America here. If you're anywhere on this path, you have a pretty good chance of seeing that occultation. So, if you're, well, you can sort of see, if you're in, looks like it's going to be going north of LA, up through Nevada, up through Wyoming, up through Montana. I don't know my Canadian provinces. Saskatchewan, Alberta, Quebec. I'm not sure. I think this is Alberta. That's going to go over, yeah. But anyway, I don't know if you can see this on the screen or not, but there are little numbers here: 10, 15, 20, 25, 30, 35, 40, 45. That corresponds to the minute. Okay, so it's starting at 2 hours 7 minutes. So here's 2 hours 10. Here's 2 hours 15, 2:20. So you can see how fast this thing is moving. Okay, it moves, basically from the northern edge of the United States to the southern edge of the United States in about 7 seconds. Okay, so this mother is moving. That is moving fast. Be it as it may, it's probably a pretty large asteroid. The asteroid number is pretty small, so that means it was discovered long ago. There are about 750,000 known asteroids now. So this is asteroid number 388. So it was probably discovered way back when, and is probably pretty large, and that's why the duration of the occultation lasts that long. Yeah, I know the picture froze. I think, I can only assume that was me. So because it sort of froze up here too, could be the ISP. I don't really care. We're in a circle of friends here, so if somebody has to exit, or we have a time warp of some sort, it's like, well, hey, that's just part of the fun. I don't care. Yeah, but I'm extremely glad that you come back, and yeah. OMC Triple X is watching and making dinner. Yeah. I am with you. Anyway, back to the occultation here. So this is a pretty cool site. We can go back here. What it also does is it gives you star charts. So you have to be able to find this thing, and this happens to be. You can see this is a pretty wide field of view. Here's Gemini over here. Here's Auriga. Here's Taurus. Here are the Pleiades. Here's the Hyades. So Orion's going to be down here, I think. And this little X right here across, I can zoom in a little bit there. That's where the star is. All right. So then you can go to a narrower field of view, and it zooms in a little bit more. And you can go to a narrower field of view, and it zooms in a little more. And you can go in and in and in until you get a really small field of view. And that's how you find whatever star you are looking at for the occultation. And this mofo is a faint one, really faint. Going to be hard to see. not impossible, but yeah, that's going to be a tricky one because the brightness of that star is really, really, really small. The magnitude scale um, in astronomy is sort of counterintuitive in that the larger the number, the fainter the star. So excuse me, a 13th magnitude star is much fainter than a 10th magnitude star or a 0th um, um, magnitude star. Vega is sort of the standard 0th magnitude star, and everything sort of fulcrums off of that. So Venus is about a magnitude negative point. I'm sorry, a -4. The Moon is like -12. The Sun is -26. And every step in magnitude. So the difference in brightness between a first magnitude star and a second magnitude star is 2.5. So a first magnitude star is 2.5 times brighter than a second magnitude star. So it's a logarithmic scale. That's just that's sort of the best model for how our eyes actually react to light. Um, Lord is not getting audio. Uh, okay, maybe that was before. Yeah. Because I'm hearing good audio now, so I'm just gonna continue on and ignore the Lord. So yeah, we can sort of move through these. There's another site. Maybe I'll blast over there. Anyway, check this one out. This site is very, very cool. There's another similar site, and I'm going to try to find it here with Google. So you get to watch me fumble around. It's called Bright IET asteroid. Yeah, pointysource.com/new. So this is pretty much what? That's not quite what I'm looking for. Asteroid events, is that it? Yeah. So this is pretty much the same list, right? We can actually go to the same event here if it's listed. Yeah. So here's 388. Okay. This has the nice feature of going to Google Maps or Google Earth. And so you can actually zoom in. And see, so there's the entire path. And so I'm going to zoom into the United States because that's sort of just where I am. Times, and I've got to move it. You know the drill here. It's so I don't know why that came up. So now I can zoom in a little bit more. We can sort of get into the details here of what's. So this lines here are the theoretical edges of the asteroid. So that's how wide the shadow is going to be. So anything between those two dark lines, at least according to the orbital elements that they have, that is where, right? So yeah, it's just going to be going. If you're living in like Bakersfield, you might see it. You see that it's just on the edge there. It's north of LA. It's going right through Death Valley. And as you recall, it's actually going this way, right? Going through Yellowstone. If you live in Billings, Montana, you will definitely see it. right? I want to know if I was right. Oh, it's Manitoba. Okay, it's going through Manitoba. Yeah. So this is a pretty cool thing, right? Because you can see the entire, because this is a flat projection of a sphere, the path is going to look curved because it's essentially just a great circle. So yeah, this is a really cool site. And how do I get back? Oh, I see. It popped into a new window. Okay. But yeah, basically, the same information here as well. So I will make sure to post this um, uh, to the description as well. Note that this doesn't really indicate any kind of location. So you sort of have to use both of these sites. Um, what I do is I use astro-art.com to look for locations that are near me, and then I will go to this site, pointsource.com, and pull up the Google map and zoom in and see actually how close it is predicted to get to me. But actually, what I use, and I guess I'll stop sharing for now and go back to this. Hopefully, yeah, I'm back. Actually, what I use is a piece of software that is called Occult 4, and it's occultation prediction software. So it pulls in all the orbital elements of several thousand asteroids. It doesn't have them all in their database. You can enter that information. You can go to a place like the Minor Planet Center and get the orbital elements from them and enter it, into Occult, and then run it that way. And Occult, you can also use a number of different uh, star lists. Depending on how faint you have to go, you have to use different star lists. And these star list, as the name applies, is just a list of stars and their positions. And so if you have the orbital elements of the asteroid and the positions of the stars and your location on the Earth, then you can predict when a particular spot on the Earth is likely to see an occultation. So that's what I use, is Occult 4, and I will. I'll. I can probably find that if you want to indulge me for a moment. Occult 4 asteroid. Up here. Occult 4 asteroid. 0.2. Let me share the screen again. Whenever I share the screen, I think I have to like sing a little song or something. So that's what that's all about. So I'm going to share the screen. And it goes to infinity. And then I can go over to Occult. So they're up to version 4.2.0, which, hey, that's kind of an interesting version, huh? You know what? That number comes up a lot in my life. Don't quite understand why or how, but there it is again, live. I'm not messing around with that. Anyway, so this site, it's, a very basic site. You just, it's got a few instructions and a couple of links, to you grab a zip file, a couple of zip files, and install it. And then there's a pretty lengthy procedure to, get all the star catalogs loaded and the asteroidal elements loaded up, and you have to, know your latitude and longitude and elevation, and all of that. But you get all that set up, and if anybody needs help with that, you can certainly get a hold of me. And in fact, I should have mentioned this earlier. If you want to be on the panel here, as soon as I go live, I get a link. And so you can just email me anytime at cosmiclettuce@gmail.com, and I will put you on the panel. I think that would be awesome. And haha, I have a kitty in the lap. Happiness is a kitty in the lap, right? Yeah, yeah. Can you say hi? I don't know if anybody can hear you. Probably not. Let me tilt this down just a little bit. Yeah. Okay. So anyway, that's what asteroid occultations are all about, and they're really cool. If you haven't seen one, it's sort of, it's a mini eclipse, really, and every location on Earth, you will have the opportunity to observe a dozen of these a year, maybe one a month, one or two a month, really. And if you're willing to drive, maybe a 50-mile radius around your location, you can probably maybe close to 100 of these you can observe per year. That's probably a slight exaggeration, but yeah, they're happening all the time, and they're pretty cool. And people who are really into these things, they have video recorders that have, the timestamp to the millisecond on the video itself. They encode, the timestamp on the video. So they just record the occultation with the video, and then do the analysis afterwards, and figure out exactly when the occultation started, when the occultation stopped. The other really cool thing about recording it like that is if there's anything interesting, right? And there are interesting things around asteroids. There's an asteroid that we know of right now. It's asteroid Chiricahua, and it was determined to have a series of rings around it. So it's very cool. They observed this, sort of a faint dimming, followed by a really deep dimming, and then followed by a faint dimming again. And it's like, well, holy shit, there's rings. There's rings around an asteroid. So very cool. It's just absolutely fabulous. What I do when I'm out observing an asteroid occultation is I will take my it's way over there, my shortwave radio, and I'll tune it to one of the WWV channels. The WWV is hey, cat is the time, is the universal time. And you can hear this over shortwave. And so what I do is I will have the WWV running. And hold on, let me grab my. I don't think I can see. As soon as this chair is much wanted, and so as soon as I leave, somebody jumps up into it. Anyway, shortwave radio here. I don't think I can hear anything inside, but I'm going to give it a try anyway. There it is. Yeah, that's too hard to hear. It's all that you guys are going to hear is a bunch of noise. But if you can get the WWV over shortwave, now you can't listen, you can't cheat and go to like an SDR, like an internet SDR, because there's going to be a time lag there. So you can't use the internet for this. You have to use radio, shortwave radio. Is it? I think it's. Yeah. Anyway, look up WWV, and so what I do is I have that ticking away in the background, and I turn on an audio recorder that can hear that going off. You know, tick, 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 and I, you know, prior to all this, I have found the star that's going to be, I'm going to be occulted. So I know where to point, and 10 or 15 minutes before the predicted occultation at my location, I'll start the recorder, and I'll start looking through the eyepiece. Now this kitty wants out, and if I don't let her out, she's going to completely destroy the entire universe that I'm in. So she's currently ripping the fabric of space-time. So I will be right back. Come on, baby. Come on. All right. So, yeah, maybe 10 minutes before the occultation is supposed to take place, I will start my audio recorder. And I'll stick my eyeball to the eyepiece and start watching. And when, I have a pretty good idea about when the occultation is going to take place, and I have the time, I'm listening to the time. So I've got a really, really good idea about, when this is supposed to happen. And at the appointed time, I really start, to concentrate looking at the star. And when I see the star either dim, most of the time the stars will disappear, right? Because the asteroids themselves are really, really dark. And so, the star will actually vanish. And as soon as it vanishes, I just yell. I just go, hey! And when it comes back, I yell again, hey! And so then I take the audio recording and I throw it into Audacity, and I look at the waveform, and I can see, the seconds I'm ticking off, so I know what time it is. And most recorders are recording at 44,100 samples per second. So every second I've got that many data points. Now I have wrestling cats, and with wrestling cats, they are dealt with a little dihydrogen oxide. No, yes, dihydrogen oxide. Dihydrogen oxide. Cats do not like dihydrogen oxide. I'm telling you now, they just don't. They just don't. Especially when it seems to be coming from nowhere. It just completely confuses them. And they stop whatever they're doing. So anyway, I put this audio file into Audacity, and I can distinctly hear tick 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 marks, and I can also distinctly hear when I give out my little shouts, and so I can you have to allow for reaction time and all of that, which I do, but you can get to a good fraction of a second precision just using that method. And for the most part, that is good enough. Now, if you're using a video and you're recording at 30 frames per second, then you're going to have a precision of a 30th of a second, which is much better than, say, a fifth of a second, which is sort of a normal reaction time. Yeah, so that's how I do it. And I haven't observed an occultation in quite a while, but one of the really, really cool things about observing an occultation is that you're actually seeing something happening. Okay, for the most part, you go out either with or without a telescope or binoculars and look around. There's not much happening, right? The stars are twinkling, but they're all in the same place. Depending on the season they move, and the time of night they move due to the rotation of the Earth, blah 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 blah. But things don't seem to be happening all that much. So when you an occultation and actually see that something is happening in real time, and it's happening fast, right? I mean, these things last just a few seconds. It's very, very cool. It's a rush. And it's fun. It's fun, and there are. I'm trying to remember. There's an organization. Go and file a report on your observation, and then they put that in the database, and it's a data point. It improves the orbital parameters of the asteroid. I think I've said this already. Yeah, so every new piece of data just allows us to know a little bit more, and that's part of what science is all about, is trying to learn more and more and more. So very, very cool. Asteroid occultations are extremely awesome, and yet if you wait for like a 10th magnitude star to be occulted, then you can get away with an 8-inch telescope or a 6-inch. telescope. On rare occasions, a very, very bright star, like a visible star, will be occulted. Those are pretty rare because there just aren't a lot of bright stars. There's a lot more faint stars than there are bright stars. In fact, maybe I will leave you with that. Let me find. There's a really, really cool list. Number of stars versus the brightness of stars. Let me see if I can find it here. Number of stars. Stars for magnitude. For magnitude, let's see if I can. This might be it. Do, 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 do. Am I freezing up again? Damn it. I am. Okay, this is not the site. Right. Stars can be observed, apparent magnitude, stars of the sky. Yeah, I guess I'll have to look around for that again. I don't have that on this particular machine. Okay, well, I think I'm going to. Okay, yeah, well, cool. I've been watching my YouTube stream here, and it's been a little choppy. And even the live thing that I'm looking at on this screen has been a little bit choppy tonight too. So yeah, whatever. What can you do? It's fine. Don't matter to me much. I'm just making an observation that it's occurring when I just mentioned that a number of other shows like this were having some technical problems today. So, maybe it's just today. Who knows? So anyway, I think I'm going to get out of here. And I will see you again in a little over 22 and a half hours. So, make sure to hit that subscribe if you haven't already. Hit the like on there for sure. Share the video around. I definitely I want this whole thing to grow, and I want the circle of friends to just get larger and larger and larger. And I think I have found a vacuum in sort of the astronomy internet universe that can be filled, and that is having a daily live show that is very casual, but also very serious. I'm not trying to screw around here. I'm this is a lot of fun, and when I have fun, I'm at least very, very sincere about it, if not very serious about it, because it's a passion, and I think a lot of people have a lot of interest in astronomy, and this is a different approach to that kind of a discussion. It's just not providing you with facts and news and information, but yeah, just having a chat about things astronomical. So yeah, I'm going to get out of here, and I will see you again in 22 and a half hours. All right, peace out.